Okay, so my rating for this scene scientifically is a 3 out of 10 because while the scientific aspect of it is possible, it's not probable, and it could only happen under extreme circumstances. But as far as likability goes, I gave it a 10 out of 10 because this comes from one of my favorite movies and one of the movies that I've seen as a child and growing up. So of course I'm a little bit biased. I'm partial to it. So. Okay, so to analyze, or just I'll give you some background on the scene first before I begin to analyze it for scientific accuracy. The movie, of course, is set primarily in Halloween Town, so the scene that I chose, which is the final scene, and it's only right that the movie would end in the same place that it began, which again is Halloween Town. This scene is primarily when it begins to snow in Halloween Town, and it ties in ideas of previous scenes and provides proper closure to the movie. In Halloween Town, following the return of the Pumpkin King Jack Skellington, it snows for the first time ever. The people of Halloween Town, who are only vaguely familiar with the concept of Christmas and the idea of winter, are astonished by the idea of fluffy white ice. In reviewing the scene for scientific accuracy, I found a couple of issues. The most prominent of those issues involved temperature and state change, in my opinion. In the beginning of the final scene, Santa Claus passes over Halloween Town with a bellowing, "Happy Halloween," and as Jack Skellington replies back, "Merry Christmas," it begins to snow. Almost immediately after the snow begins to fall, citizens of Halloween Town are shown skating on ice. Now, it is true that perhaps Halloween Town was already cold, but it would be unrealistic to say that the temperature was below freezing. According to a weather report posted by the National Weather Service, the average Halloween temperature in Chicago is 50 to 59 degrees Fahrenheit. I chose the city of Chicago to represent Halloween Town because of its already chilly nature in order to be fair. The graph I used is shown below in the document that I will be uploading. Assuming that the average temperature on Halloween in Chicago is an accurate portrayal of the typical temperature of Halloween Town, say roughly 55 degrees Fahrenheit, then it is scientifically impossible for the water to be frozen on any given day. Rather, the water would simply be cold. Granted, the water may have frozen as a result of the obviously cold or snowy weather. However, the lake is shown frozen only 16 seconds after it begins to snow. It is common knowledge that 32 degrees Fahrenheit is the temperature at which water freezes. Since 55 minus 32 is 23, we know that the temperature would have at least needed to drop 1.4 degrees per second for the lake to be frozen on the top. Indeed, the temperature drop to 32 degrees Fahrenheit would only be freezing the water closest to the surface. According to the Smithsonian, lakes can take several weeks to freeze through. Due to the rapid decline of temperature, assuming that it continues at the same rate, the lake could potentially be frozen solid in a matter of days rather than weeks. The website Outdoor Canada, in an article advising those that ice fish, designates the perfect conditions for a lake to freeze quickly. Slight to moderate wind speed, no snow on the ground, and clear skies. These conditions are exothermic in a way because they allow heat to be pulled from the lake. Wind speeds allow for a chill, lack of snow allows for the wind chill to be effective, and a clear, sunless, and cloudless day would prevent any natural heating of the lake.
Okay, so I did chemistry. I did a scene about chemistry in The Nightmare Before Christmas, and the rating for the science in the movie is a 3 out of 10 because a lot of the things that are happening aren't very realistic, and I'll go into detail later. But overall, I didn't really like the movie to my personal liking, and I would probably give it a 5 out of 10 because I'm not much of a Halloween person. I like Christmas a lot more, and I thought it took Jack Skellington way too long to figure out what was so special about Christmas. So for my scene, I did the scene where Jack Skellington is trying to figure out why there's so much happiness within Christmas, and he takes an ornament off a tree and crushes it into a beaker of boiling water to see how powerful the chemical is and how powerful the spirit of Christmas is. And so the reason why I gave it a 3 is because it wasn't very realistic, but the reason why it did earn a 3 is because there was adequate lab equipment used in the scene. The water is being boiled with a Bunsen burner, and in chemistry we have used this for past experiments for heating up water in different methods and everything. So when I first saw the scene, I automatically noticed that the single flame coming out of the Bunsen burner was orange. So it's safe to assume here that the flame is an example of incomplete combustion reaction. And unlike the dangerous blue flames that can also come through the burner, here, because it is orange, there's not a sufficient amount of oxygen within the yellow flame, and when the methane gas comes out of the Bunsen burner and is mixed with oxygen in the air and the carbon monoxide, it yields and produces carbon and water. And so this incomplete reaction is used to boil the water that he later puts the components of the ornament in, which in the beaker there are both chemical changes and physical changes when he crushes the ornament in the beaker. And the first chemical change is the production of gas when we see the formation of bubbles and fizzling. Because the styrofoam little beads and balls were dissolved in the water when it bubbled, this changed the physical shape and state from a solid to a liquid, and because of this it's inferred that a chemical reaction has occurred. And we can also observe a physical change in color from clear water to green, and this green is not just a color, it actually is glowing, and this is another example of a chemical reaction producing light. And in chemistry we do see some reactions giving off luminosity, but some light is not able to be seen with the human eye. And last year we studied that there's a visible light spectrum, and because it was a glow light of green color, it was most likely UV light based off of that spectrum.
Okay, so I chose to do the physics portion of this project for The Nightmare Before Christmas. And my scene begins with Jack Skellington in the sky here. And he is delivering presents to all the children in the city, and all the presents are scary and dangerous, so he's being reported to the police. Therefore, the police have known that there's a Santa imposter, so they're shooting at him. And eventually they do shoot down his sleigh after they take this last aim. Well, now that he's shot down, you can see that he is at the level of the clouds, and as he falls, he actually hits the surface of Earth within a matter of seconds, and I think that is very inaccurate. So I decided to look up the height of the clouds, which came out to be 6,500 feet, and I converted it to meters, and I was going to use mechanics and Suvat to calculate the amount of time that it would actually take to fall to Earth from that height. And so I decided to use the equation s equals ut plus at squared, 1/2 at squared, and so I first started out with the x and the y. However, he's only moving in the y direction, so the x does not matter because the initial velocity and the height and everything, and the displacement and everything for the x equals 0, so therefore it does not matter. And in the y direction, the acceleration is constant at 9.8, therefore his weight does not matter because I considered about how he's only a skeleton versus a human being, and bones only weigh about 15% of a human being. But since weight does not matter in the y direction, that can all just be ignored. So I calculated it out, and the time for him to actually fall would have taken about 20.1 seconds, which is a lot longer than portrayed in the movie. Therefore, the scene is inaccurate. However, some of my coworkers, their project and their scenes came out to be somewhat accurate and some are inaccurate. Therefore, I would say that if I gave an overall science rating, it would probably be about a 6, because also I cannot blame them for not wanting to show the movie for like about 30 seconds or 20.1 seconds of how long they would actually fall, so they shorten it to keep the audience entertained and cut out unnecessary footage. So I would have given it about a 6. Overall for the movie itself, I'd give it an 8 or 9. I always loved this movie as a kid, and I always thought it was pretty great. So yeah, I thought my scene was pretty inaccurate and that it could be portrayed a lot better.
I'm doing the biology portion of the Group 4 project. And the scene that I chose to do was the scene where Sally the ragdoll jumps out of the window in her high tower, where she's being held by Dr. Finkelstein, and she lands, and we see that her limbs have detached from her body, where she then proceeds to sew them back on and function and move as normal. So, for movement to happen, an action potential or impulse has to be sent from the brain through the nervous system down to the muscles. And for muscles in particular, there's something called a neuromuscular junction. What happens is, once this action potential reaches a neuromuscular junction, it triggers the opening of sodium ion channels, and then this causes an influx of sodium ions. The sodium ions then trigger the release of calcium ions, and the calcium ions bind to something called troponin, tropomyosin molecules, which are basically proteins that facilitate muscle contraction. At rest, tropomyosin covers sites on action where myosin can bond, but when calcium bonds to the troponin, tropomyosin molecules, then troponin changes shape, like it's like a rod-like structure. It kind of changes shape and pulls back to allow access to the binding sites that are underneath. After the action potential has passed, calcium channels close and calcium ions are removed from the cytoplasm in the system. Since there are no more bonding sites, because the calcium has been flushed out of the system and the troponin returns to its regular state, this is basically facilitating the relax of the muscles. The muscles relax. ATP is actually very important in all of this. It facilitates the sustained contraction of the muscles as well as the release of them. Now, ATP is produced through aerobic and anaerobic cellular respiration. And so when a body dies, there is no more oxygen being circulated through the blood system, to allow oxygen to be supplied for aerobic respiration, which means the body resorts to anaerobic respiration, as well as a whole bunch of calcium ions eventually start leaking from all this extracellular fluid, and they actually bond to the sites like the body was still living. And so calcium ions, after they bond back to the troponin, tropomyosin molecules, the muscles contract, since that's what they're supposed to do, and myosin cannot detach because there's no ATP to help them. Then the muscles remain contracted. This process continues and the whole body becomes rigid. So this puts practically movement out of the window for Sally before she even jumps and falls out of the window and lands. With the muscles rigid, and since she's made of dead body parts, they would be so stiff, and there would be no flexibility, no bending of any joints, even though if they're attached, because he's basically like one solid plank. And so even if she were alive and her nerve impulses were traveling all the way down to her body and allowing for the relaxation of muscles, the brain would have to be able to send signals to those muscles and stuff. And since we see in the movie where her arm and leg and other limbs are clearly detached from her body, and she sews them back up with a doll needle, even today, the restoration and reconstruction of neural pathways is very hard to do. The technology we have one technology where you can use some sort of metal to help facilitate the sending of the impulse, where it's like you have metal, you have a sample of metal like infused with skin, and you put that in. Anyway, even with that technology, movement would not be 100% restored, and with a ragdoll needle, it's impossible for her to be able to patch up all the neurons and neural pathways needed and required for movement to happen. So, the axon on an average nerve is only about a micrometer in diameter, and when you try and patch that with a doll needle, the range is anywhere from 4 to 7 inches. That's highly improbable. And so, overall, the scientific aspect of my scene wasn't that great. The rigor mortis would prove that, movement would be practically impossible, as well as there is no signal to facilitate movement in the muscles because, her neurons have been separated from each other, and there's no possible way that she's able to fix them. The scientific aspect of this scene is not probable at all. And so the rating for this scene out of 10 for pure science, I would have to say a solid 0 or 1. I mean, she's someone made out of dead body parts, and she's not going to be able to move or patch herself up and move afterwards. And so For the movie itself, I thought it was a pretty fun movie. It's a little creepy for kids and all that, but overall I enjoyed watching it. Brought me back to my childhood. But anyway, the movie itself, out of 10, I personally would probably rate it at about 6 or 7. It was all right. It was decent. And then I actually talked to the other members of my group, and we decided to rate it. They had similar ideas. We rated it a solid 7 or 8. They thought it was a little bit better than I did.